Hello, everyone. Just 1 second as we set everything up. Are you in Twitch, Bruno? Can you check it?
I'm opening Twitch. I can see I had an error.
Okay. Let me see
Okay,
the chat.
I can see it now.
Great. We have no one yet live with us, but hopefully we'll start getting people in. If anyone's in, I see that we're getting some people right now. If you could please confirm that that you can see us, that'll be great. Otherwise, we'll just begin with our chat today, if that's okay with everybody.
It's okay with me.
Okay, let's wait just a couple of minutes so that we can give people some chance to join us. But hopefully soon we should have it. Let me update over here. Okay. So I think we can start. And first of all, thanks to everybody for joining us today again. This will be our third live stream. Today we'll give just a brief update on the production process, just so that everybody knows how we're doing with the production process. And we will also be talking about the two main developments that we've been working on. On that note, I think we can start. First of all, in terms of the production process, we've already been able to acquire the final component of the Kceptor++. We're pretty happy with that. That's a great milestone that we've been waiting for so far, and we're quite happy to have that element in our hands. As we may have said in a previous Twitch live stream that we've had, the main element of the Kceptor++, this component that we've been referring to, was the most unique impediment that we've been having with the production. So we're quite happy to have achieved this, have been able to acquire this units. Additionally, as we also talked about, I think it was during our first live stream, if I'm not mistaken, they'll correct me on that if I'm wrong. We've also had to redesign the PCB, as one of the components that we wanted to get was out of stock, and we changed it for another one, so we had to do a redesign over there. As we speak, the PCBs are being produced, and they should arrive pretty soon, if I'm not mistaken. Bruno, am I correct?
Yeah, they should be arriving. We are currently near the New Year's Eve in China, which is where the PCBs are produced. And we might have a little delay on that, but basically they should be arriving now.
There you go. So yeah, that's also out of the way. Okay, they're being sent, so we know already that we have them. So after we get those PCBs, since we already have all the components for the Kceptor++, what we'll be doing is producing a test batch. Okay, so a minimal batch, just so that we can confirm that everything's working accurately. After that, once we've done the testing on that initial testing batch, we'll be able to go to production, which is what we've been waiting for all this months. Okay, so we're quite happy to be able to say that, and finally, just having some units of those initial Kceptors that we will be testing out. Just be aware that we'll surely be so excited that we'll probably be spreading the word out and showing you guys the Kceptors as soon as we have them and we can test them out. We'll try to provide any videos or images as soon as we have them. Okay, we have to move fast, obviously, but since we'll be so happy, I think we'll be able to get some images of those units. After that, the only element that we're missing right now is the final element of the hub. So far, the providers have been sticking to the commitments that they had in terms of dates. So this final element should arrive soon. I don't want to give any dates just because even though we have a confirmation from the provider, as Bruno said, we have the Chinese New Year. All of the components, most of the components come from China, so we have the Chinese New Year in the way, and we also have the international shipping situation, which so far hasn't caused many delays, but you never know. So we don't want to give any specific dates, but so far the providers have been pretty strict to the last dates, at least that they gave us. It seems like the market's sort of coming to a point where it looks like what we had a couple of years ago in terms at least of stock. Nothing like what we had in terms of pricing a couple of years ago, but at least in terms of stock, we're seeing that finally we're catching up. It seems like providers are catching up on stock. Okay, so those final units that we need for the hub will be the last element that we will need in order to go to the final production of the hubs. The hubs, as you know, it's only one per unit. So it's not as huge of a production as the K-Scepters. It's not as sensitive as the K-Scepters, okay? So that will be something that we hopefully can clear out pretty quick. And so far it looks like the first semester goal that we had in mind is going to be achievable, okay? Again, just give us your kindness as we're still having to deal with some uncertainties that have come up due to COVID-19, but just have it at hand, okay? So just have it in your head that we may have some minor delays, but so far things are looking pretty good, okay? And I don't know if you have any, I think I've covered everything that we had, Bruno, in terms of updates on the production. I don't know if I missed anything in terms of the updates that we wanted to give everybody.
No, I think you covered it completely.
Great. So on that note, we can move to the developments, okay? Now, on a previous Twitch, if I'm not mistaken, the second one, we talked a little bit about the developments that we're doing, that we have been applying. You know, we've been using this time in order to incorporate new tools to the system. We're going to talk about the main two development processes that we've had so far. And I'm going to just give a brief introduction so that Bruno can cover all the technicalities of each. The main one has been the implementation of the calibration algorithm that we've had developed, and we've done it through the Blender add-on that we already have. The reason why we've done it through the Blender add-on is just for simplicity's sake, first of all. Blender is an open source system, so we always like to work with them, and we're pretty connected to the Blender community, so we want to have our tools available for the Blender users as fast as we can, but also because it will be the best way for anyone that has a Chordata beta testing kit to be able to test out the new calibration algorithm. So also, as soon as Bruno finishes just speaking about the development, be aware if you have a beta testing kit that you should be able to test this out. I don't know in which date. Obviously, developments are more of Bruno's ground, but sooner than later, you should be able to test this out. So feel free to do so as soon as you hear the news on this update. Okay. So Bruno, on that note, I don't know if you want to get a little bit into this development.
Yeah, let me share my screen. Hope you guys are seeing everything. You can see the Blender screen.
I think we can. Yeah.
Okay. So yeah, as Juancho said, this is one of the main developments we're carrying out in these weeks. As you know, we're currently working in several pieces. Like the Noto core is still going, and I will share you some other updates with you after this one. But one of the main things we're doing right now is implementing this calibration algorithm directly in Blender. I don't know if you recall from a past video, like this algorithm was already done and we had great results. I show you a comparison. In the left, you have the new algorithm working with a capture take, and in the right, you have the one that is currently implemented out there, and you can use in the current version of the add-on.
So sorry, Bruno. Sorry to bother you, but we had a little technical issue. If you could repeat that, because the screen was completely black for just a couple of seconds over there.
Okay, but I was saying that as you know, this calibration algorithm was already done, but it worked offline. We gather like offline capture data, and then we pass through here in order to develop it. And I will share with you some more details about this workflow in the next update I will be doing in this stream. But for now, we had this. Okay, this algorithm was working, and it was giving us great results. As you can see in the left, I hope you are seeing it now. You have the new algorithm working, and in the right, you have the one that is currently implemented. That was the legacy calibration algorithm. And as you can see, the results are great. Right now, what we are doing is like taking all this code base, which was directly developed in Python, and we are like put it in here in the new version of the Chordata add-on that will have some changes, and most noticeably the armature node. I don't know if you remember from the past. Let me show you. For the current version of the add-on, it only has one button to calibrate, but right now you will be shown 3 buttons, and the new calibration will work like this. You will have a static calibration that will be very similar to the one that we were doing, where the performer just has to stand up, and the calibration will be done just with this standing pose. In comparison, this new calibration algorithm works like looking on every single, direction or cardinal point. The previous one, you have to look straight out, so this is a much more advanced algorithm. And you will also have the opportunity to make what is called a functional calibration. Apart from like standing there, you can like perform, I don't know if you see it here, you have 3 types of functional calibration. One, you will have to move your arms, and the information of the movement will be used to calibrate the arms. Another one, you will have to walk a few steps, and the calibration from the movements of the legs will be used to improve the calibration of the legs. And for the last one, you will make a movement. We will explain all this movement later, but you make a movement which is used to calibrate the torso and the head. And by the way, this little discussion that came out inside the Chordata team, as you know, many of us are not like native English speakers. So this discussion was regarding the name of this part of the body. It's like the torso and the head. We just call it trunk, but one of us is saying that should be called torso. I don't know quite if you had a word on this. It's not really a huge deal, but
I know I do a good job in terms of hiding out the fact that I'm not a native speaker, but but I am not, so I wouldn't be able to say. But if anyone in the community, we have a lot of native speakers, so if anyone in the community has a correction on this, that'll be more than welcomed. I think torso would be. I think my guess would be that torso is a better translation, but I'm not 100% positive on that.
But it's torso plus head. So
there you go.
We can just call it torso, and it will also work.
It's just or head plus torso calibration. Yeah, we may go for that one instead. Yeah.
That's it. Yeah, basically, you as a user of this new calibration algorithm, you will be able to do like first a static one, and then optionally one or all of this one. Also, looking at the results of the static calibration, and these are great because they work in. They doesn't use the magnetometer at all during the calibration. So even if you had a magnetically disturbed environment, the disturbances won't be reflected in the calibration by using these functional calibration types. Okay, so this is one of the main things we're doing right now, like putting all this algorithm in here. So in the next few weeks, we will be able to release this new version of the add-on, which comes with several bug fixes and minor improvements here and there, but the main improvement is this new calibration algorithm right here. So yeah, once it's out there, it would be really great if you guys, the ones that have a beta testing suite or a self-built suite, to try this new algorithm on and just give us feedback. We're sure we will have some things to fix once it's out there and you guys are trying it. So as always, your feedback is precious and it really helps us push the development forward. So yeah, expect some news soon and please try it out and let us know. So that's most of it for this part. Shall I continue, Juancho, with the next big development we're doing right now?
I think we can, yeah. Just to introduce it for for a bit, to give a few notes. Bruno's about to talk about the main development that everyone has been asking for. We announced we announced it. I think we did some mentions of this development and how it was evolving during through our social media pages. I think it's one of the publications that has had the best reactions so far. So we know that this is really important for you guys. And what I'm referring to is what it's referred to in our community as root motion or gate motion. You can also think of it as spatial translation. As we know, this is one of the main how would we say limitations with inertial technologies. Okay. So we've been able to develop a system that will tackle this at a software level. Okay. So on that note, you can correct me if I said anything wrong over there, Bruno. But I think you can get straight to the gate or root motion. Okay. Many people refer to this with these two names. If anyone has clear accuracy on which one should be the most correct from the engineering perspective point of view, that we should use. We also refer to it just colloquially as spatial translation, just for everybody to understand. So yeah, on that note, Bruno, I think you can get to it.
Okay. Yeah. So yeah, the problem with this is that in scientific biography, you have a lot of names depending on the area of application of this algorithm. But yeah, like basically, root motion is what our community was using, so we normally refer to it as that. So basically, I would like to share with you some of the workflow that we do or people normally do when developing algorithms like this, just to let you know some of the insights of what we are doing. So basically, we start with some takes. We export these takes as a format that is easily readable by the languages that you normally use to develop things like this. And namely, in this case, this is developed in MATLAB. What we are seeing here, because I'm on my Linux machine, is not MATLAB, it's Octave, which is an open source interpreter for MATLAB scripts. And yeah, what they're showing you here is the code that we have right now. We have been developing, like as with the calibration algorithm, offline versions of this in order to get things moving and developing the algorithmical part of it. And we have some results that we already shared with you on our social networks. I will show to you again. Like, for example, this is a linear walk. As we told as we said in our social media, it's almost done, and we have some minor fix to be done here. But basically, as you can see, the first thing we wanted to achieve is like the avatar moving in space. And yeah, the complication of this type of algorithms, as Juancho said, is that naturally what inertial sensors do is to collect and they are able to accurately describe the rotation of the piece of something that is attached to. Okay, so with that rotation in a jointed structure like this, like a skeleton, it's quite easy to. It's not easy, but it's quite direct thing to do to reconstruct the inner pose. As a position, when you need to reconstruct the motion, the errors that not a regular sensor that the one that we use and everyone use, MEMS sensor, are so big that it normally drifts away really quickly. So you have to develop, just to let you know some of the insights of what is happening here and why this was the last thing to be developed in our system, is that we need to detect when one of the foot is stationary and we use that period in order to like reset all these cumulative errors that the sensors normally do when you just directly integrate acceleration. That's what we are getting from the sensors into translation. Okay. In order to do that, you have to do a double integration, and the errors there accumulate in an exponential way. So just to give you guys a couple of insights, as you can see, one of the steps of this calibration algorithm, this translation algorithm, is to detect the situation in which one of the feet is stationary, and then we apply a series of corrections into the integration of the acceleration to translation, and we get the results that you were seeing. So that is where we are right now with this part of the development. We are very excited with the results we're getting. And yeah, what we have right now is like the complete algorithm implemented in MATLAB. And what we will have to do right now is to translate all this code, which is in MATLAB and working in an offline manner, into a C code, which should be performative enough in order to perform online, like live, like process the live stream of the capture data and give us results. So this will be a development that will take a couple of months. So we will surely be delivering the suits without this, and when they will add it to the software that we will use. And another thing that is important to emphasize here is that we are currently only working with Blender, because in the background we are also developing an abstraction layer that will run directly on the notochord, and that will enable the implementation of several clients, which is why one of the reasons why Chordata, the Chordata Motion framework, is so useful, the ability to interact with several softwares. Right now, many of the algorithms are implemented in our main client, which is the Blender add-on. But working on this abstraction layer, we will be able to like implement and process several of these algorithmic layers directly on the Raspberry and send already calibrated and already translated data to the clients. So this is something that is happening, and we wanted to share with you the state of this development. As I said, we are currently like putting all our efforts on delivering the suits as soon as they're ready. So as soon as we have the first test batches, we will put all our efforts in testing them, and then deliver everything, and then we will tackle this part of the development. Okay? I don't know if I cover everything, or I left something, Pancho. Do you have?
I think you did. I think you can go back to your camera, by the way.
Okay.
But
1 sec. Yeah.
But yeah, I think we've covered everything we've had so far. As always, remember everybody that you have this chance to send us any messages in case you want any questions. You want us to answer any questions at this point. We're obviously quite happy to. I think we're not seeing you, Bruno, for some reason.
For some reason, you're not seeing me, but I should be.
Maybe. No worries. So yeah, be kind.
I'm here.
There you go. I know. That's for sure. But yeah, be kind to us in the sense that we're doing this. We're not experts in terms of live stream. We do this just to get to hang out with the community every now and then. But yeah, if anyone has any questions at this stage, this is the perfect time to ask them, and we'll give just 1 or 2 minutes in case anyone has them. And if not, I think we can move on and continue with those developments. Remember again that all of this live streams will be posted to YouTube. So if you missed anything at any point, you can check out the complete live stream. Probably tomorrow we'll be uploading it. So feel free to check out our YouTube page. Give us likes and comments and all of that fancy things that the algorithm likes. You'll be promoting Chordata with that. And I think we have no one asking any questions at this point that I can see, at least.
We can mention Juancho, we will be in.
Oh, that's really important. Thanks for that, Bruno. So yeah, if anyone wants to join us, if anyone happens to be in Barcelona, we know we have a pretty international community. But if anyone happens to be in Barcelona for the Mobile World Congress that will be taking place in a couple of weeks, we'll be over there. We'll have our own stand. So feel free to check it out if you're over there. We'll be happy to talk to anybody from the community if they want to say hi. If you're gonna be there and you want to talk to us, send us a message. And our website, you have a form where you can send us a message, and we'll be happy to exchange a few words with anybody that happens to be in Barcelona at this time of the year. Okay. Thanks for reminding me of that, Bruno, because that's an important announcement. And but I think with that we can finish it up for today. We'll be announcing new live stream sessions as soon as we can. We do them. We try to do them on a monthly basis. Obviously, the end of the year stopped that from being possible. But we also wanted to wait a bit because we knew that we were getting this last components that we needed, and we wanted to give that update here in the live sessions. So probably we'll have another one throughout March. We'll be announcing it through our social media. And yeah, on that note, I think we can end it up for today. If that's okay with you, Bruno?
It's okay for me.
Great. So thanks everybody for joining us, and we'll be seeing you soon.
Bye, everyone. Even if you can see me,
you're a huge bee, so you can say goodbye as a huge bee. Great.
Goodbye.